Let's get this started. Welcome to the inaugural Base58 encoding, which is a funny pun we've been waiting to do something with for many months. Yeah, so I'm Kody. I help Lisa teach Base58. Lisa, you want to introduce yourself?
I'm sorry. Yeah. Hey, I'm Lisa. I started Base58 the beginning of this year. We teach Bitcoin protocol stuff. Right now we've got a Bitcoin transaction class. We're in our fourth one, technically, third cohort. And for the summer, we thought it'd be really fun to do a series of cool open source projects that we like with people we like that work in Bitcoin part and full time. Yeah, so we're just kicking it off with the project I work on at Blockstream called CoreLN. It is a Lightning implementation written in C. We pride ourselves on being we call spec first. So if you want to add it to CoreLN, you gotta add it to the spec first. We're mostly in C, though we recently changed our name from C Lightning to CoreLN because we now have some Rust code in the main binaries. Not purely C anymore. Cool. So I think Kody's gonna take us through maybe like some of the links and stuff. And then I will go ahead and show you, I guess, like do a
Yeah. So I just
I'm gonna do so.
Yep. So I just put a bunch of links in the chat.
Okay.
Yeah, I just put a bunch of links in the chat, and those are going to be just for following along. The big ones are this is the link to the GitHub repo for it, and so this is github.com/elements/projects/lightning, and so this is this is CoreLN's out of the Elements project. You can follow CoreLN on Twitter and there. For Base58, we're base58.info, and we've got upcoming Taproot class that has a waitlist open for, so you can sign up there. And then the one that I did for this, just to like kind of help everybody out, was so Lisa and I put together this this Replit for kind of walking through CoreLN. And so what this does is it kind of walks you through the code base, but also walks you through like spinning up in a regtest environment, a Bitcoin backend, a couple of Lightning nodes, how to connect them, and like open channels, and kind of works you through everything and explains what's going on along the way. And so if you guys follow this link, which I'm going to put in the chat again, but if you follow this link, it'll bring you to the public REPL that we made. And so what you're going to want to do, if you don't have a REPL account, just sign up for one, and then you're going to want to go here and fork this REPL. Right. And so once you fork it, you're going to be able to follow along, do the code, and change it as we go along with this. Right. And so yeah, but let's kind of go along with that, and I'll walk you through this one, and then Lisa's going to walk the base, but after I kind of show you what's going on in this REPL. Right. So in here, it says failed to connect, retrying. That's excellent. Okay, so in here we've got a bunch of different stuff, right? And so this README is going to be your entry point, and it's kind of just like a tour of CoreLN. It kind of tells you like what CoreLN is, how it works. We cloned down the Lightning repo into here, so you can actually look at the code and what's going on if you want to. But we also have Bitcoin and Lightning in the REPL, and so you can from the shell execute all these commands. So if you just go here and click on shell, you can execute all these commands, spin up the regtest environment, actually go through, connect your nodes and all that kind of stuff, right? And it's kind of like just a tour of like how CoreLN works, like the plugin architecture and all that kind of stuff that Lisa's going to go over. And so that's all the links. I'll just keep posting them. If you guys have questions, I'll try to answer them in the chat. But Lisa is going to take over, and she's going to kind of like give you a tour of the repo and how everything's organized, like how the code works, all that kind of stuff. So I'm going to stop my screen share, and Lisa, you can take over.
Cool. Thanks, Kody. Do we want to like walk through the Replit, or are we just gonna do? I can just do my. I can just talk. I'll just talk.
Yeah.
Cool.
Let's do that one, and then we'll go to the Replit after for like actually going through code, maybe. But
yeah, that sounds good.
It's got the instructions in there, so everybody can follow along.
Follow along and stuff. Yeah. So I think one of the fun ways, I think I'll do some of the stuff that's like in the Replit, because that's kind of a fun way to check out stuff. Let me check out master. I've been working on some stuff. Cool. So great. So for those of you who are new to CoreLN or Lightning in general, maybe I should talk a little bit about how Lightning works. Just kind of do like 10 seconds of overview of what a Lightning channel is and kind of how that how those sorts of things work. And then once you kind of have a decent idea of how a lightning channel works, or how like what is lightning, kind of give you some background motivation, we can start kind of looking at how core lightning is architected as a project, which really what we'll get into is like all the little daemons. Core lightning is actually pretty cool in the fact, in terms of how it uses like Unix processes to do multi-threading, but so I'll show you what all that means in a little bit. But before we get started, let me just go ahead and do a classic Base58 style intro to Lightning. Cool. So for those of you who are familiar with Bitcoin, hopefully that's most people. Bitcoin is kind of like considered like there's like the layer one, so to speak. This is like everything that we teach in our Base58 transactions class is how to make Bitcoin transactions and transact on kind of the main chain, so to speak, right? But if you want, so Lightning, on the other hand, is kind of considered something that we call like a layer two. One thing that I should have mentioned about layer one, for example, that kind of makes understanding layer two easier is that layer one's like when you make a transaction, you send it to everyone on the network. So like a good analogy that I used for an interview a few weeks ago is like, it's kind of like being in a giant like football stadium. And if I wanted to send Kody, who's standing right next to me in this football stadium, like, I don't know, 3 Bitcoin, big spender. I don't know, maybe we're doing a real estate deal in the football stadium, who knows? And so I'm gonna give him 3 Bitcoin. I'm gonna write up a little transaction. And then I need that transaction to end up with every person in the football stadium, right? So I'm gonna start handing it to the person next to me. They're gonna hand a copy, they're gonna make a copy and hand the copy of this transaction to the person next to them. And everyone in the network is gonna get this transaction, make a copy of it, hand it to all the people that are standing next to them. And then, so eventually this transaction, and what's on the transaction is the words like, okay, Lisa is paying, you know, Kody 3 Bitcoin. Everyone in the stadium is going to end up with a copy of that transaction, right? And at some point that'll end up in a block. I'm going to kind of like hand wave exactly how that happens. But the general idea is that you make transactions, and on the main layer, everyone gets an updates about everyone else's business when transactions happen, right? Which is kind of like fine, I guess, but also kind of cool. Okay, so Lightning is considered layer two. The big difference between layer two and layer one is that in layer two, not everyone finds out about your business. So generally the idea, like kind of the core insight with layer two is that you can make like a contract between 2 parties. So a lot of like the original Lightning paper, which I think came out in, I'm gonna get this wrong, 2017, 2016, somewhere around there. Maybe 2015, I don't know, the Lightning paper, which is honestly a lot harder to read than the Satoshi white paper. It's like 50 pages long and pretty dense. But yeah, so it's a contract between 2 parties. And part of the reason that they kind of think about it that way is that the Lightning paper was really a marriage between this like idea of code as law and blockchains. So the whole idea is that like you can make a contract between 2 people by publishing a Bitcoin transaction on the chain that locks money into a account, so to speak, that both those parties have to agree to move like the money, so to speak. And then so you publish a transaction, and in that transaction, it's basically the way we do this in Lightning specifically is we make it 2 of 2. People who know stuff about multi-sigs will know that if you have a 2 of 2, in order to spend it, it requires a signature from both parties, right? So as soon as you have this like contract, basically, which is a 2 of 2 multi-sig output on chain, now in order to spend it, you need a signature from both parties. And all of a sudden, this means that both parties have to agree on what is in any transaction that spends that output. And so this little like insight gives you the ability to like keep your balance. So you can create a balance where there's like 2 parties, right? So let's say that we both lock, let's say we lock 1 Bitcoin into a 2 of 2. Lightning kind of, I guess we call these funding transactions. What happens when you do so then when you have the one Bitcoin in it, and we have two parties, right? Who owns what percent of that one Bitcoin can be negotiated off chain, so to speak. And you do that by exchanging signatures for the two of two that's on chain. And as long as you don't submit any current, as long as you don't submit these like signatures to the chain, like the current state to chain, the channel stays open. Okay, cool. So Lightning, there's also a lot of other stuff about like routing payments. Once you have all these like little contracts, you can kind of route them together. So there's like routing payments together as like a whole nother part of Lightning. There's also like, how do you close a channel? How do you keep your peer from cheating? How do you keep your peer from cheating? I think that's like basically it, right? Like you create these little two of two outputs, then you have like a whole separate accounting system, which is what the Lightning node does, and keeps track of who owns what in each channel. Then you have like this ability to kind of send and route payments, send, receive, and route payments for other people as a node on the Lightning network. And then at some point you close the channel, which is basically like ending your contract, ending your two of two contract that you set up at the beginning, which basically you do by spending the output with the two of two. It's not really that complicated. You spend it. And then your peer there's this whole thing about your peer cheating, trying to spend an outdated state, etc. And that's like where you get into stuff like penalty transactions. And that's also where something like L2 is like really around this too. It's like, it has to do with that whole thing. Okay, cool. So I think that's like a pretty cool that's a pretty high level intro of what Lightning is. So one thing that's kind of cool is that then we took those, what do you call it? Let's see what I have this open to. Then we took kind of this like general idea of what Lightning could be, and a group of people got together in Milan and wrote up something called the lightning bolts and put together 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think I miscounted. No, I think that's right. There's like 11 bolts. They took all these like kind of ideas about how they wanted it to work, and they wrote down actual messages and little protocols. So when you have two nodes that are existing, it's how do they set up? So they kind of wrote out how a computer talking to another computer would negotiate like that starting contract, the two of two. How do they like send each other information to route payments securely and successfully in such a way where you don't have to trust the other party? They figured out how to establish like a communication protocol that's in bolt 8 as it's called. On chain is what happens when you like go to close the transaction. So what happens when both parties agree about how to close that contract they had? What happens if they disagree about how to close the transaction? That's all in one of the bolt 5. Bolt 4 is all about how you send payments. That's onion. We call those onion routing. After we use the same or very similar construct to how Tor does packet routing. So Lightning has its own custom onion configuration stuff that we use. 3 is all about the transactions that we use. 2 is all about how you talk to another peer. I don't know what 1 is. I never look at that. 9 is about features. I guess those are features that the nodes can advertise, etc. And then 11, I don't know what 10 is. I've never looked at 10. And bolt 11 then is about like, how do you tell someone about a payment that you want them to make for you, etc. It's kind of a invoice. We call bolt 11s like invoices basically. And that's like basically where the specs are. So Core Lightning then is a, let's see, I can pull up the GitHub, lightning.com, Allotments project. So Core Lightning is a, like we said earlier, a C implementation of the spec. It's written in C. It's what I would call like extremely Unixy. So if you're used to running like Bitcoin D and Bitcoin CLI, Lightning D also has like a Lightning D and a Lightning CLI, so to speak. So it's very similar to the words, Lisa, very similar to Bitcoin D that way. So in the same way, kind of like how you can look at all of the settings that you can set on a core Lightning node with help, which is kind of cool. So you can set up on testnet, mainnet, signet. It's got a bunch of experimental features, that kind of stuff. Some dev options, which are really nice when you're trying to work on dev stuff. So if you're curious about like what all the settings are, etc., you can always ask for help once you have Lightning D set up. Cool. Okay. What else? Okay, cool. So maybe we should like go ahead and kind of, let's see. I'll set up like startup reg test, which is one of my favorite little tools for kind of running a little running a Lightning node locally on reg test. And make sure that we configure ourselves for a local developer, right? So this is a local fast start option. It lets you just kind of spin up some nodes locally once you have the software built. And this is going to be what you're going to use in the Replit that Kody put together. If you want to walk through doing all this kind of by yourself, there's a really great Replit for it. Cool. There's also, I should point out, if you're like trying to get started with call it, where's the docs thing? There's a whole docs folder here. If you're trying to get started with hacking, there's a really great readme on how to get started on getting started, etc. It kind of goes through what all the different libraries are, or I should say what all the different directories are on the top level, which we'll go through together, and go through some database stuff, how you can look at a database once you have problems. Maybe we can do some of that. That's kind of fun. Building, and then a bunch of stuff on how to run testing, all the different types of tests that we've got, environment variables, how to change the bolts and other stuff, etc. So this is pretty helpful list of stuff when you're writing code for Core Lightning. Cool. So maybe the first thing I should do is check out well, I'll do that later. Okay, so what I wanted to show you is this cool little thing called, I have to source this script called startup reg test. This lets me set up, I'm a little worried I'm not running Bitcoin D now. Ooh, got multiple Bitcoin Ds. Okay, let's see if I've sourced it, then I just have to start LN, start up just 2 nodes. Oh, using to load the database, it's already loaded. I think that's okay. No, it's not okay. Let's see, let's test. Try it again. Cool. Nope. Sorry, I don't know. This is like clearly.
Lisa, you want to run it in the Replit? Sweet.
It's okay. I'm assuming that the reason it's failing is because maybe have to build the project. I don't know. Oh yeah, we should build a project. I forgot to do configure. So the first time that you get a new, like download a brand new version of Core Lightning. So let's assume you just like get cloned. You just clone like GitHub, whatever, the Core Lightning project. The first thing you're gonna want to do, I think, is run after you've like downloaded. There's like a whole list of I don't know what you call them, like apt-get like packages you have to download to help you build the project. But before you build it, you're gonna want to run configure. Configure is pretty cool. It gives you a list of options of things that you can like disable and enable. I want to be in developer mode because I am a developer. This will also make all the tests run faster, which is always good. I also want to enable, I'm going to enable, I don't know, I'm going to enable I'm going to disable Rust just so maybe that'll make my stuff run faster. And I'm going to enable experimental features, maybe. Let's see. Nope. enable experimental features. Watch this like blow up my build. Oops. So then it's going to do some configuring, which is just like setting up some build flags basically. So whenever you run make, all of these little, so when it says it's setting all of these little environment variables, so to speak, this is what the environment variable is going to be when you run make after this. So this is like sort of the process of like checking that you have all the right libraries installed, okay, etc. Cool. Okay, and then I'm gonna run make. I like running J, which means to do jobs. If you want to be safe, or if you're running on a computer that like doesn't have the most horsepower, you want to make sure that you like give it a number of processes. So like nproc, in case you're wondering, is how many processes your computer has. So I'm going to run make, that'll build the project. J means kind of like number of jobs, so it does it in parallel. You don't want any more than the number of processes you have on your computer, because you can really like weigh your machine down if you just give it J without a number. It'll just do infinite, or as many as like it can possibly spin up at the same time. And then yeah, I'll do that. I usually also type quiet just so it doesn't populate, doesn't like print out a lot of stuff, but sometimes it's kind of fun to see what all the commands that make is running. Just fun. Like I said, like Core Lightning is very like old school Unixy. Like we've got make files, we've got yeah, I guess that's like kind of the extent of it, is make files and stuff. Make files and stuff. Okay, so that successfully completed, which is great. Then you would run sudo make install, and I would install. Oh no, I typed it in wrong. Then it installs it locally. So now my like lightning-d that I have here is gonna have whatever the latest version is. That version seems really wrong. I don't know why that is. Let's see what the lightning-d version is. It's the same. Okay, interesting. Definitely on master. I don't know what's going on with that. Oh, I see. Okay. I would expect this to be 11.2, but maybe that didn't get pulled back into the main line. Anyways, I'm kind of just like, okay, cool. So we're running a modified, this bit at the end tells you what commit you're on. So if you do get ref parse head, these first little characters here tell you what commit you were on when you built it, so to speak. So if you ever have a question, so if I'm on like a checked out release or like a tagged release, it'll just have the version number, which we go to here. But since I like did a custom build, I'm on master, which is kind of at a random point. We always add the patch number, so you can find it later if you for some reason have a question about what lightning-d, like which patch your lightning-d was built from. It'll always be printed in the version, which is pretty cool. Okay, let's see. Okay, cool. So that's built. So now I can do stop ln. I already did this. Let's start ln. Let's work now. No. Yeah. Okay. Now it's working. Cool. Cool. So this get CLI. Cool. You can see it. So like, I guess like, oops. Clip this. So I use Vim for my like work stuff. So I'm going to be looking kind of at the project through Vim, but maybe it's easier just so you guys are, maybe it's easier to see where I'm headed if I look at it from GitHub, which is not a problem. So the little script that I ran is in here. It's called startup-reg-test. It's got some comments on how to load the file up and then start some nodes, and then you can get info about the nodes and connect them. One thing that I kind of wanted to point out is this, the L1 thing is an alias that gets set. It's actually just calling lightning CLI and pointing it at a directory in our temp folder. So I could, instead of typing L1 CLI, get info, I could also type lightning up here, for example. So this won't have L1 CLI because the aliases haven't been loaded in. I could still call it though by calling lightning CLI, lightning directory, temp, L1 reg test. For better or for worse, oh, I didn't give it a command. I don't know, get info. So that gives you the same thing. I just wanted to show you what that L1 CLI means. We're really calling lightning CLI and just pointing it at the directory where the node got, like basically the node directory got set up We can look at that node directory. Maybe that's interesting. And also note that like for startup regtest, it always puts stuff in the exact same directory, which can cause some problems. Like I had to like go in and delete all my stuff out because like I had old stuff in there. But I find it really useful for like quickly iterating on stuff if I'm trying to like code up a feature or something. It's kind of nice to be able to like run it locally really quickly. Right, so I wanted to show you and what's in this lightning directory, so you kind of have a decent idea of like what are all the parts of a core lightning like install. Let's see if we look at, so that's it, temp L1 regtest, we're on regtest. Okay, so there are, like print it out a little. Cool. So there's 1, 2, 3, 4 things in this directory. It's a lightning directory. The first is a config file. Whenever I ran lightningd help, it printed out a bunch of config options. So if we've decided to set any of these that are going to get applied every time that we start up a node, we would add them to our config options. So let's see what we've got in config right now. We can go temp L1 regtest config. Cool. So I've set the network to be regtest. I want all my log level to be debug, right? Because when I'm developing locally, I really want to see all of the stuff that prints out. If you're running Core Lightning more, I would say hobbyist, you're not like actually actively trying to work on it. You probably don't want to set this at debug. It'll fill up your disk pretty quickly, especially if you don't have like log rotation set up. This is where it's going to print out the log info. So we'll look at that in a second. This address tells it where to make itself available for other nodes to connect to. So we just use localhost, which is also the same as, this is the exact same as 127.0.0.1, I think. So you can get that the same place. We're using some dev options. So we want fast gossip. This will make it such that my little L1 nodes will find out about each other really quickly. It also pulls the Bitcoin D thing that I've got running in the background really fast. So if any new blocks happen, we'll hear about them more quickly. Without these options, our stuff would run a little bit more slowly. There's just like a little more wait time between making things happen. So again, in order to make these like work, you're gonna have to make sure you do run configure with that enable developer option on, which is cool. Cool. Also, we turn on experimental dual fund by default so that we can set up some liquidity ads by default. So my node that is running, in their funding, I don't have a max my funding. That's cool. Okay. So we'll talk a little bit about, I think the little like exercise I wanted to do today, we're going to try and fix a bug. It's around like the liquidity ad stuff. So that's kind of fun. Cool. Okay. So that's the config file. What else was in here? We also have this PID, which is a process identifier. So I think if we cat this, if we cat it, that was not what I wanted to do. Cool. So if we cat temp L1 regtest, what's in lightning-d-regtest.pid, it's just a number, which I think if we do the PS tree of it, so this is the process, PID stands for process ID of my daemon. So whenever you start up, lightning-d, it starts running in a process, and then it's also going to build kind of like a whole process tree underneath that. So whenever we look at the process tree with the process numbers, we're going to see like all the little things that are running under lightning. So you have lightning, and then you've got, so I've got core lightning kind of just running here. And then it's got a bunch of like little other processes that are running as children, so to speak, underneath it. So one cool thing that maybe we'll get into a little bit today is everything in here that starts with lightning is part of the core lightning project. So there's one that starts with like connect. This one's called gossip. This one's called HSMD. If we switch back over to the project over here, whoops, so back to core lightning main, you'll notice that there's like some of these folders end with a D at the end. So there's a channel D, a closing D, a connect D, a gossip D, lightning D. Those are all the like daemons that make up a core lightning node. And so lightning D is kind of like the master node. He hangs out over here. and then he creates a bunch of children. So all the ones that start with lightning underscore are going to be little daemons that are coded up or implemented in each of these little subfolders, so to speak. So let me see who else is in here. Oh, these other ones that don't have the lightning underscore at the beginning of it are actually, these are actually plugins. So these are all going to be implemented as little C projects or programs. So each one of these is like an independent C program, right? Each of these is going to have its own main function that gets called when it gets started up as a project or like a little program. All these little ones without like the lightning-d at the beginning are stashed in plugins. And so let's see, there's like one called auto clean. So we can find the little program that's running in the process. So this is the process number of this like auto clean little app, or I should say like running program. If you come in here to plugins, we can find the auto clean little program. So this is the thing that's actually like running. It's very short. It's only like 100 lines long. It's all written in C. I think these are all C ones. So these are kind of all the ones that come automatically built in with Core Lightning. So we ship with like a set of, these are like the kind of the core plugins that get shipped with Core Lightning. And some of them, like some core functionality is actually implemented as a plugin. So for example, pay is like a plugin. There's a pay plugin. So when you call like L1 CLI and then you call pay, it will, sorry, CLI pay. It will call it through a plugin, which is kind of cool. The ID. Oh, that's interesting. Okay. 3774174 is not what I was expecting. That's okay. I wonder what this is. Sorry. We like added some new stuff. Sorry, I'm just like, we added this like tracing thing so you can kind of see where a Core Lightning command comes from based on the ID of a request. So it'll let you trace. So if you send a request, it'll let you trace it through like the pay. Pay will then send your command over to lightning-d, who will then send it to a lightning channel, which you can't see here. So yeah, so the way that like Core Lightning works is like if you want to like pay an invoice, for example, you're going to call a command called an RPC command, which is added to Core Lightning through the plugin. And then when you call it, you're going to like send a little message that message will actually end up over in this process, the pay process. And then once pay sees it, it's going to start sending out messages using kind of pipes, like Unix pipes. It's going to send messages over to like lightning-d. And then lightning-d will delegate questions and answers to all of its little sub processes. So those are the ones that start with lightning underscore, right? So if you want to talk to a lightning underscore process, you're going to have to go through lightning-d. It's kind of like the bouncer for all these guys. But all of these other little plugins, these guys all talk to lightning-d directly. Right. So basically, anytime you send an RPC like command, it goes in first through lightning-d, and then they'll figure out where to route it, whether that needs to go to another plugin or if that needs to go to a like a subdaemon to handle, etc. Which is pretty cool. I don't know. Okay, so I'm pretty into that. Cool. So I wanted to see, oh, maybe this is just an ID of a request. I think this is just a request identifier. But it's cool. It's telling you that I'm coming from the Lightning CLI. So I'm initiating this request from the Lightning CLI, which is pretty nifty. Okay, cool. Where was I going with that? There's somewhere, we talked about pay, we talked about plugins. Oh, looking at the auto clean thing, right? So one of the best ways to read like Lightning, like Core Lightning or any project at C is usually to start at the bottom of the file. That's because like as you go upwards, every like command that you need here, so to speak, will get called farther up. So this is a really short plugin. It's got some options. So you can set these options in. These options will show up in the options when you call lightning-d help. I can make this big so we can see them, and then I can look for them. It's called like auto clean, right? Yeah, so you can add, it's cool, like plugins can add options to Core Lightning, which you can set up in your config file, etc., which is pretty nice. Okay, cool. So those are plugins. Oh, okay. So we were walking through, sorry, we were walking through what all is in the core lightning directory, and we got a little distracted because I wanted to look at what all the different plugins that are running are. It's also got a log file, so we can look at what the log is. Note that this log file isn't like set up, oops, it's a directory. Oh yeah, I need log. So it's got like, it prints out all the logs for your node. It shows you, this is kind of cool. You can see the plugin manager where all of these little plugins get started, where they're getting started from. They're starting from my build directory. This is where I like built and compiled Core Lightning. Cool. Checks the plugin stuff. This is where it starts up all of the, well, it's testing some stuff, but these are all the little sub daemons it's going to start up. These are all the daemons that lightningd has. There's only 1, 2, 3, 4, 5, 6, 7 of them. And for the most part, like with the exception of HSMD and gossipd, the other ones are kind of correspond to like phases of a lightning channel lifetime. So there's a point where you connect to another node, which we'll do here in a sec, and is also in your REPL. Once you've connected, you can start opening a channel. Then you'll move into the other like opening daemon that has all the logic about how to open a channel. Once you've like gotten the channel mostly opened and done kind of the opening dance between the two nodes, and you've sent out the transaction, like your initial contract that's going to lock that 2 of 2 on chain, you're going to move over to channel D. Channel D handles like we're routing payments back and forth. At some point, you might decide you want to close your channel. Then you'll move into this closing D period where you're negotiating a close with your partner. This is only really used in like the case where you're both decided you want to close together. And then finally, like your little 2 of 2 contract will end up back on chain. And that's where on-chain D takes over and really monitors the end of the life cycle of a channel till the end, etc. gossipd and HSMD, I'm not really going to talk about that much. HSMD basically manages your private keys, and any request to sign Bitcoin transactions happens in that process. And then gossipd has to do with like how you get and send information about nodes and channels on the network. And it handles like connections to peers. Well, it handles, connectd handles all the connections to all your peers. Gossipd handles all the messages that are considered gossip messages. And I think you can see those in, I think we can see those in, if we go back to the bolts, let's see how far back I have to go to get to the bolts. The bolts. So if we go to the bolts, there's like a whole gossip bolt. Should I click on it? Yeah. It's got 1, 2, 3 messages in it. This one doesn't count. Ignore this one. These 3 are your gossip messages. Those messages that are sent and received are all kind of managed by this process here. So your Lightning node will really only have like 1 gossip D, 1 connect D, 1 HSMD. But the number of channel Ds, closing Ds, and on-chain Ds and opening Ds that you have really will depend based on how many channels you have, etc. Cool. Okay, so I'm gonna go ahead and maybe make some interesting stuff happen by connecting these guys. In order to connect 2 nodes, I need some information. I need to know, oh man. I need to know the ID and the connection information, address, etc., and port of a node I want to connect to. Out on like normal like Lightning network, you can see all this data through the gossip stuff, but when you just kind of have a network like at home, so to speak, with 2 nodes, you have to look up the info, so to speak. So I get the connection info from L2. I'm going to use that connection info to connect from L1, right? So L1 is actually going to call connect. I'm going to call it on this node ID of L2, and I'm going to use their address connection info. They're on localhost. And then I have to give it a port, which is 7272. So that's how it knows how to connect to it. It connected really fast. So now L1 is connected, but what's really cool is you can check and see on the other side, if you do list peers, you'll see that L2 also connected. So L1 called connect, but since, it's a connection, it's like an edge between 2 points. Now L2 also considers itself connected and can see L1, even though only one side said connect. Both of them know about it. Should have called list peers before it was not up there. I guess I can disconnect. I called disconnect. Gotta disconnect from this guy. So now if I do, they should both be empty. Yeah. Cool. So I'll just reconnect really fast. Cool. Okay. So now that they're connected, if we look at this process tree again, do we have anything new? We don't have anything new, do we? Okay, just kidding. It's hanging out in Connecty. Cool. Okay, so if I actually want to like show a different channel D show up, I need to actually create a channel. In order to do that, I'm gonna need some Bitcoin. This is all in the REPL too. This is all stuff that you'll walk through. Get info. I have a lot of money already. I don't have to mine any blocks like you guys are gonna have to from your cold start. So I'm just gonna get a new address. I'm gonna send some money to it. Oh my gosh, dog. I'm gonna send, I don't know, I'm gonna send myself 10 Bitcoin. Sure. That sounds good. Okay. And then B2 CLI get new address. Hey. I'm gonna send some generate to address. I'm gonna mine a block. This is like local stuff. Okay. So now if I list funds, I'll see some money in there. Cool. So I have 10 Bitcoin in my 10 Bitcoin in my outputs. Pretty cool. Cool. It's confirmed. It's in a block height. It's got like drip pub key and stuff. Okay. That's cool. So now if I wanted to open a channel between L1 and L2, I could say I'm already connected, right? I'm going to use the fundchannel command, but I always forget like what kind of stuff you need to put into fundchannel, so I can ask help fundchannel. This is going to open up like in the docs. There's this whole, there's a whole, nope, that's wrong. Oh, that's dark. Why do I always get that wrong? It's cool. So in the docs, there's all these like, so every RPC call that we write for Core Lightning for the most part also has a man page, and they all live in doc. The .md is like the markdown version of it, and then we kind of compile it into something that the man page, I don't know what you call it, the man page system can like understand. So what I just did is I'm looking at the Lightning Fund Channel doc, which is written here. It's in doc, so I can open that up so you can see it. Doc Lightning Fund Channel .7.md. So everything in here is what I'm looking at here now, which is cool. It's nicely formatted as a man page. Right. So if you have a question about a thing, you can call help and it'll open up the man page for you, which is kind of nice. This is a lot of info though. And like sometimes all I really want is to know what the parameters are. So if you say -j, that'll mean print out just like the JSON information, which is a little more compact and just tells you like what all the options are that you can put into a command, which is nice. Cool. I'm assuming that there are, oh, there are chat. Okay, cool. Sorry. I don't know what multi-channel functionality testing variances. I don't know what that means. Okay. Okay, cool. So, all right. So if I wanted to fund a channel to, I gotta see who my peers are. This guy, I want to fund a channel. So this guy who we all know and love is L2. So I'm going to do L1, CLI, fund channel. Kind of nice is to have this little, I could just do channel and then amount, like, I don't know, like 100,000 sats. That's 1 Bitcoin, isn't it? No. I don't know how many, I'm really bad at counting sats. What if we do like, it's much better for me to do this BTC. So you could open channel that's like this big to peer 2. So you kind of just do them in the order. Yeah, okay. I think that's cool. I think that'll work. Great. Okay. So what just happened is like my channel, if I go back to the PS tree. So now there's a new like little process running. We used to have 3 that were lightning. Now we have 4. This is the one that's kind of monitoring this channel open. So it's like this dual open D command, not command, dual open D REPL thing. Words, Lisa. So if I go back to, let me go back to Elements Project Lightning. So it's an opening D. There's a little, no, it's going on. No, that's wrong. I clicked on the wrong one. If I go to opening D, not on-chain D, there's this dual open D daemon. And that is what is currently running. Again, it's got like a whole little main statement here at the bottom. So it's like a little program, it's running. Now it's got a little loop in here. It's got a little while, not message, it's got a little while loop, so it'll run until something happens and then we exit. Cool. So what's the thing that it's waiting for? It turns out the thing that it's waiting for in this opening thing. So this is kind of useful. If I do L1, list peers now. Oh my goodness, there's so much more information. It used to just be connection info, but now we actually have a channel. We can see what state the channel is in. We can see what if we close the channel right now by ourselves without asking our peer for help, we see what the transaction ID would be. There's a bunch of different information in here. It tells you what daemon it's currently in. I think that's right. Yeah, tells you what daemon it's in. It's in the dual open D daemon. See that there's like a transaction in flight. So we're currently waiting for this transaction to finish opening, so to speak. This is our commitment transaction ID, which kind of cool. You can see what your starting balances are, the local and remote did, and if we push them any sats. Cool. If you do like if you do a liquidity ad and you push sats over, this will say how much you paid them as a fee for that channel. And then you can see kind of where the state you are, we're in waiting for lock-in. And that's kind of the whole thing. So the way that L2, if you do the same thing, you'll see the same thing. It's kind of just the other side of it. See all the other side's info. Okay, so what I want to do is I want to kind of lock my channel in. So I need to generate a couple more blocks. I'm going to generate like 5 more blocks. And then because we have those dev fast gossip and dev like quick blockchain Bitcoin D like polling happening, it should move from so it should move from waiting lock-in to locked-in normal pretty quickly. So locked in just means I published a transaction that had that 2 of 2 contract in it. It got added to a block and then that block made it to like a couple blocks deep. Can't remember how many we say it has to be. So if I check the process tree now, you'll notice that dual open D has disappeared. And now we've got a new and different one called channel D. Channel D is like the normal channel operations, like daemon, so to speak. So he's running right now. You can go find all the code for channel D over here in channel D, channeld.c. That's you. Excuse me. Cool. Okay, so that's like how the daemons like sort of, and so here's like its main function when it starts up. So one thing that's kind of like interesting and fun, I think, to look at when you're like, okay, but how do all these daemons like talk to each other? What's like the process of them like sending messages around, etc. I see that they're like clearly talking to each other and stuff's happening, but how does that happen? And so I think this is kind of interesting. Cool. Okay, yeah, so now my channel's open. Trying to think if I could make it go to on-chain D, but yeah, it's fine. Okay, cool. This way we can like send payments and stuff, I think. Cool. Okay, so let's talk a little bit about how daemons communicate between each other. So like from lightning-d to channel D, for example. I think this is pretty interesting and it's like really strongly tied to how our lightning channels, so each of these channels then will also talk to like another peer, right? We use these things that are called like wire messages. Did I finish getting through? Sorry, did I finish getting through like this temp thing? I don't know if I did. I looked at the log. Sorry. I don't want to get too far off. Reg test. What's in reg test? Oh, I didn't look at this. Yeah, that's fine. So that's some other stuff. We didn't finish talking through all this stuff. Okay, let's talk through this and then we'll go back to how do the daemons talk to each other. Just to like finish out kind of like my tour of what is in a core lightning like directory. So we kind of had this top level that had the config for the node, the process ID of the currently running node, a log file that we told where to put in the config. And then it has this directory called regtest, which has more stuff inside of it. So when we look inside of regtest, we can see this little file thing called the RPC. This is the actual like thing that Lightning CLI is sending messages to. So actually when we call something like help, for example, so if you call lightning CLI help, notice this is different than calling, this is actually an RPC command. Oh my God. Oh, great. L1 CLI help. What this will print out are all the different commands that you can call on lightningd. And the way that that like is asked, it's actually sending like an RPC request. So it's kind of like a meta RPC request. It's like, okay, what are all the other, if I call help, what are all the other commands that I can pull back? I think you can see help in here. Yeah, so there's a help command. So if you call help, it'll tell you about the help command. Cool. It's also how you get info about a command, etc. So whenever you like issue a command from the CLI, it actually sends that command to this file descriptor on the file. I don't know how you call it. Sends the command through like the Unix pipes to this file descriptor as a Unix pipe. And this is how you actually send and receive data into the core Lightning daemon thing that you see in the process tree. So this guy is listening at this like file descriptor on your system, and by like piping text to it is actually how you are sending data to and from lightningd. It's all formatted, so the data that this file like understands, so to speak, is all JSON 2.0 stuff. So Lightning CLI is like actually just building little JSON requests and sending them over, piping them to this file descriptor on your machine. Lightningd is listening at this like file descriptor. Basically, it reads in data when you send it to it, parses it out as JSON, and then figures out based on the JSON that you sent it where to route that command. So it'll have like a command name and then some parameters, and it'll figure out based on the command name where to send it. Maybe to a plugin, maybe to a daemon that it's managing itself, so to speak. Cool. Okay, what else is in here? There's this thing called the gossip store, which like if I like try to look at the gossip store, it's gonna be really sad. It's like this like gossip store is kind of like a weird, maybe we should come back to the gossip store. So if you think about a database, so this is a database file, right? And this is a database file that's written in a format that like a database project called SQLite 3 can understand, right? So this is like some data on disk that's formatted in a special way that SQLite understands it. Gossip store is like very similar to a database, except it's more like, you guys know how like way back in old computer history, there used to be something called tape stores. And so if you wanted to store data, you would like write your data to like a tape, so to speak. Gossip store is kind of like an enormous like tape storage system for gossip. So when we get gossip messages in through from our peers, we're going to write it to disk in this like tape storage system that Rusty wrote. It's very similar to kind of a tape thing. It's just a long file with like byte, we remember like byte positions basically to know where things are. But yeah, that's basically the gossip store. So we can like look at what's in there. I actually don't know what kind of, it's just gonna look like, see anyway, it's a binary file. I'm gonna say yes, and it's just gonna dump out a bunch of junk because it's not human readable, it's computer readable, right? I don't have like I think there's some tools for reading the gossip store, which are in DevTools. So I think that those are, so you can create a gossip store. Is there a dump gossip store? There is a dump gossip store. Okay, what happens if we use this? Oh, wow. What if we take DevTools and we try dump gossip store against this gossip store that I've got? I don't know what this is gonna do. I've never done this before. This is gonna be fun. Regtest, gossip store. Cool. So what it dumped out, this is kind of cool. It's kind of hard to read, but you'll notice if they're numbered, this is number 1. This is, oh, it's not numbered. So the numbers I think is like the byte offset of where that message starts in the file, right? It tells you what version of Gossip you're running. We're running Gossip version 10, right? That means all of the records that are in this Gossip file are going to have correspond to like a structure of data, which is known as like number 10. So if you get a Gossip store that's got a version you don't understand, you'll know to like throw up and like not try to parse any of the data because you won't understand it. So that's what the version number at the top of the store is for. Then it tells you the channel announcements, channel updates that you've gotten. What's cool is that these things map to, let me go over to, I guess I just open up another thing, go to lightning bolt. Oops, lightning bolts. So these actually map to, if you go to the Gossip onion routing, no, not Gossip, Pride and Gossip. If we go in here, Gossip routing, these three messages, there's three different types of messages. We have a channel announcement in here. We have 2 channel updates. The format of the data that's written into the Gossip store is actually these little things here, these messages, maps exactly to the data that you expect in the spec. And we can see what those messages look like by using another DevTools little thing called decode message, I think, and printing that in here. And it'll actually, you'll notice that these match up really exactly with these fields that you expect in the channel, like in the type, what do you call it? The message like spec for Lightning in general, right? So it's got, I think they're actually in order too. You've got 2 Bitcoin keys, 2 node IDs. So it tells you, so this little message tells you kind of like 2 node IDs. It gives you Bitcoin keys. So there's node IDs, there's Bitcoin keys. There's something called a short channel ID. It tells you the chain hash, which is like, which blockchain does this like channel belong to? This is definitely Bitcoin. I don't remember. I think this might be the Genesis block hash. Which is where that comes from. It uniquely identifies the stuff. Okay, cool. Features. Anyway, so that's kind of like where all of the anyways, that's like what the Gossip store is. It's like this cool little private database. You can see that in there. What else have we got? We have this HSM secret. This is the super secret data that is used to derive all of my private keys for like doing any kind of transaction on my node. So this is usually really good to back up somewhere. You'll need this along with your database. Well, you need the most recent copy of your database, which is really tricky with Lightning, but you'll need your HSM secret just to have any hope of like getting any data back off. If you like lose, if something happens to your Lightning node, you're gonna need your HSM secret to have any hope at all of like recovering any money anywhere. Cool. And then the SQLite thing is kind of fun. You can look at, so a lot like how we had to use the dev tools to dump the Gossip store, basically, we like dumped our Gossip store here. You can look at the SQLite database by using, if you have SQLite 3 installed, you can look at the database and see what it looks like. Regtest, SQLite, lightningd-SQLite 3. And then you can say schema, and it'll tell you what the schema for the entire node database is. So it's pretty big. Cool. And so if you wanted to like look at, I don't know, select splat from channels, is that a thing? Channels. Oops. There's only one channel in here and there's like a bunch of stuff, but let's see, like the peer ID, we can just pull the peer ID out. No. So the hex of the peer ID and the, I don't know, short channel ID. All right, cool. I don't think that's right, but anyways, maybe I have to call blob. Sorry, I like forget how this stuff works. Yeah. Anyways, okay. Cool. So anyways, there's a database. If you ever need to look something up in your database, that's like a really good way to do it. Cool. Okay, so that's everything in that's everything in there. The thing that I wanted to show you now is like, okay, so we've got like, if we look at our PS tree, our process tree, how are these things like communicating between each other? I'll go over that really quickly just because I think it's really fun and interesting. And then we can start going through the, I think there's like there's a, what do you call it? There's a bug I wanted to try to fix. So we can try and like fix we can fix a bug altogether. Or like add a feature, I guess, which might be interesting. I don't know. We'll see. We'll see how it goes. Okay, cool. So, the wrong thing. Okay, great. There's one more thing. Oh yeah. Okay. So one thing that's like kind of interesting is like whenever I called like decode message here and like pass it like this hex data, this is like an on-wire message. So these messages are like sent between lightning nodes over like basically over the internet. This is like the data. This is like almost exact data. We do some encryption so no one can just read it off the wire. How we do that encryption is like using this like thing called the noise protocol. It's basically like lightning nodes when they connect to each other use something that's basically a better like version of SSL. I don't know if you've heard of that, or TLS, which is what when you're on like the web, when you send and receive data between a server and your like web browser, it's using like TLS to encrypt it. So no one who's sitting in the middle can like read all your data and see what you're looking at. The Lightning Network decided to like use the next best, like most recently well-known way of like encrypting traffic between two nodes on the internet, or between two like speakers on like the internet and open network. So this data will get like encrypted into this cute like little lightning only noise protocol like thing between two nodes, and sent to the other node, who will then read it, decrypt it, read it off, and then parse this into like a data structure. Okay, cool. Okay, so that's the data message. This is the data message, right? It's basically like all the data in what we saw this message, which is cool. Cool. Okay, so the cool thing is like in the bolts, it specifies some messages. And so our implementation needs to know how to read and write those to each other. So we also, whenever like when these processes are communicating, they're gonna like use the very same way of like making these byte data structures they send to each other. They don't encrypt them, so there's no encryption happening when you send and receive messages between daemons, because you're assuming that there's no one else on your machine, right? They're just like writing between two file descriptors these messages. But it's kind of cool, I think, to see like how they're basically declared or set up in Core Lightning. And it's a really important thing if you want to start working on Core Lightning, to know how these guys send messages back and forth to each other. So let's see, if I ls in here, is there a way to just like ls but only show directories? I have no idea. That's a good question. Okay, so like let's look at opening D, that's, well, no, that one's kind of confusing. Connectee might be, maybe let's look at connectee. Yeah, so if connectee, no, let's do on-chain D, sorry, I'm like changing my mind. So every one of these daemons, right, the ones that end in D, have inside of them a CSV file called, it's going to be the daemon name _ wire and then CSV. So if I open this up, so I use Vim, open this up, I'm going to say OCD wire.csv. Ooh, does that work? D wire.csv. CSV. Cool. So this is like, it's kind of a CSV file. CSV is like a very loose interpretation term here. But what it does is it declares, so Rusty's got some really fun, kind of nice comments throughout the project that sort of tell you about what all these things are. It describes all the messages that on-chain D is going to send between itself and lightning-d. Cool. So like at the top, you kind of have there's like some data types in here. This is like a type, a SHA-chain is a type, parent types is a type, amount of Satoshis is a type, U32 is like a type. Some of these types you need to like have includes for. So what's gonna happen with the CSV file is if I wanted to add a new message in here, let's see, let's say I just want to like add a new message. So there's a bunch of messages. Some of them like get sent from master to on-chain D. Other ones get sent from on-chain D over to master. there's no like real hard and fast rule, but it's sort of understood that that's what's there. So I wanted to add a new one. You just like type it in. You're like, okay, I'm gonna call this message like nifty test message. Nifty test, the nifty message, and I give it a number. I just have to pick a number. It really shouldn't be another number that's in this like entire thing. So let's call it like, I don't know, 566. So I'm gonna check to make sure that this doesn't exist in this file yet. If I picked a number that already existed, like this one, it would show up. So I don't want to pick the same number. It won't compile. Oh no, is that a number I checked for? No, I checked for 66, but 33 is also not good. Okay. And then like, I don't know, I could add like, so then I'm gonna have some data inside my message. So you say, okay, I'm gonna have a data type. Here's the name of it. Here's like a unique type number for it. This type number is how whenever you get the message, you know what type of message you got. This is Nifty's test message, and we're gonna send it from, let's send it from master to onchain-d. Actually, this is gonna be really hard to make work for reasons. So let's add it to channel D, because then I can like, it'll just work immediately with my thing. Okay, change in plans. We're not adding it to onchain-d. We're gonna add it to channel D. So we're gonna go over to channel D wire.csv. So there's one over here, and we're gonna add it here. And instead of starting with 50, because those were the ones that were in onchain-d, we're gonna start it with 10. I don't know, let's add 10101. There's no message like that yet, so I'm clear to add it. What kind of message data? Since I'm in channel D now, just to follow, it's a naming convention. It might be strongly enforced. I don't know. Should we be like, how bad should we be? Let's not be that bad. I don't know. What am I gonna do when I send a message? Is there anything that, I don't know, it's fine. We'll just send it over. So then I want to send the nifty message. I don't know. Let's put like is there a way to send a string? There's like a thing called a wire string. Wire string. Cool. So I can send a wire string message over. I think you have to have a length for that. No, you can just send a wire string. Okay, so I can send a wire string type over. It needs to be of the same type though. So channel D, nifty message, hello string. Okay, cool. So I'm gonna send it from master to on-chain D. No, not to on-chain D, to channel D. Cool. So this is my little message. Okay, so now I've added a little message here. What happens if I run make? Okay. So it's like, hey, you just added this new message type. I can make this a little bigger. What do you call it? There's a message, it's saying, hey, there's a problem when I tried to make this. You're missing this new channel type in a switch that you've got. So when you add a new type, so it's cool is that this actually worked, right? It got picked up and it got added to a generated file. So we have a little like generation thing that reads in the CSV and prints out C code. And the C code that it prints out is in, if we look in channel D, but look at just the stuff that starts with channel D wire, I think. Let's see what that does. There's something called WireGen H and WireGen C. So by adding those couple of lines to the CSV and then running make, it actually changed channel D's WireGen. So when I go into here, channel D WireGen.h, for example, now when I go down to look at all these like beautiful little, keeps all the comments from the CSV thing. Isn't that cool? Remember how I wrote in that cute little test message data. So when it creates these C files, there's like a little program that runs through and creates all these C files. It'll port over all your comments from the CSV thing, and then the number that we picked will end up here, along with the name of your message. So mine is wire channel D nifty message. What's also cool is there will now also be 2 new methods that got auto generated that has a name and describes them. And it you can now like take a string and send it over, turn it into a wire message, and then you can take a message and turn it back into the string. So I think health string is just like, because I said hello, I think if you go back to channel D. No, is it in channel D? Yeah, channel D. Channel D wire.csv. I did call it health string, just kidding. Call hello. Hello string. Cool. So if I change that up and run it now, and then go back to wiregen.h, it'll be changed to say what I just named it, right? So this is cool. So it's like actively regenerating these files based on what I add to that CSV, which is really nifty, right? Because like this is a lot of code that I personally did not have to write. I just generated it, which is pretty awesome. Okay, cool. And so this is what I'm going to use now to send messages between the different daemons. So if I want to send a message from lightning-d over to channel D, we can do that now. So let's do that. Oh, so the build error is that if I go into this file, lightning-d channel control. So this is in lightning-d, which means it's part of like the monster list. Like there's like lightning-d is like probably the biggest daemon. It's got the most files. If you go into lightning-d and you go into channel control.c, and then you go to the line number that it tells you to, which is 519. Oh, don't do that. So I'm just going to go to 519. There's a switch statement where it takes in a message that we've read off of the like file descriptor basically, and it's going to match it up based on that type number that we invented. So this will peek the type out of the message, and then it'll switch on the message type. So we can go down. So the problem is that this type statement, so to speak, doesn't exist, and I haven't like put it in this case statement yet. So if I put, all that it's asking me to do is put a case wire channel D. I need to make this like problem happy. So this is in lightning-d, right? It's in the lightning-d, like, oh gosh, don't do that. This is in lightning-d. I'm gonna send this message from lightning-d to channel D. So I'm never gonna expect it to end up here. We never get these from channel D because it's a message I'm only ever going to send. So it can go down in this like stack list of stuff. Cool. Okay. So now if I try and make again, oh, it should mostly work. There's a problem. What happened? Oh, so now there's a switch statement in channel D, which is on the other side of the communication channel, right? So it's in a different daemon. So we got to hop over to channel D, channel D.c. What line number did it say it was on? It said it's on line number 3684. Wow, that's a big channel or a big file. Cool. So this is the same thing over here. So we're going to add a new one to it. So I actually want to handle it, right? Because I'm expecting to get this message from lightning-d because I'm on the channel D side now. So I say case wire channel D nifty message. I'm going to handle nifty message. And then I'm just going to return. Cool. Okay. Any questions so far? I'm like, okay. So now I need to like write this message. I'm going to write this guy somewhere. So I'm going to hop up to this other definition and just kind of copy what it does. So static void. I'm just copying this. Handle nifty message, right? I just take the struct, which is up here. And then, cool. So this might be helpful to know for those of you who are new to C. This U8 means it's basically with a star on it. Means this is basically like an array or a string of bytes. So the message data that we sent over is byte data, right? It's like a list of bytes. This is a pointer to that list of bytes. So we're going to use this handy dandy method that we generated, right? This should be if not. So we're going to try to take that series of bytes and change it into a string, so to speak. So channel D, what is it, nifty message? I don't remember. I gotta look it up. I'm really bad at forgetting things. It's fine. What was the nifty message? I gotta go back to the CSV just because Actually, I should go to the wire gen thing. It's easier to read out of there. So from wire, nifty message returns a Boolean. Here, I'll just copy this. Put it here. So from wire, if not from wire. So we're gonna try and parse it. If it fails to parse, we're gonna do something. So contacts, what do they pass in? They just pass in pure. This P thing is gonna be the message itself. So I'll just pass in message. And then what am I expecting back? I'm expecting back like a hello string. So I think I can just do. So I think I can just do const. Did it again. And this would actually be an and. The reason it's an and is because I gotta get a message gen. I don't know, gen. Notice that there's two little stars here. I only put one star up here when I declared it. The and sign adds a second star, so to speak. Cool. So that's hello star from if it sends a message over and I'm not able to parse it, there's a problem. We're not gonna handle it. We're just gonna say, hey, master is like another word for lightning, for another name for lightning-d, basically. We're just gonna be like, hey, you sent a bad message over. It was of type wire channel D, D nifty message. Oops. And that's it. That'll like just, I don't know what that does. We can go look and see what it does. It like fails the thing and it says like, hey, you failed. We failed to parse it. So there'll be like a parse error. Cool. Okay, so what happens if we actually like get the message? I don't know. What are we gonna do? Let's just like F print it. I don't know what this will actually do. Let me just print it out. No, we don't want to print that message out. We want to print out hello string. I think that works. I had a quick question about this. So one doubt I had, so to speak, I don't usually use these wire string things. I wanted to go see what this is. What's this? I just want to make sure this like wire string thing I'm doing correctly. So I'm just gonna I'm gonna go find this somewhere in pure HTLCs. So it's in lightning-d side of things. And I'm just gonna copy what we do over there. Lightning-d pure HTLCs.c 517. I'm just gonna copy this type. Oh, it's just a char star. Okay, so I did the right thing. So I'm just passing a char star. So you notice we did the same thing. There's one star, but you put a little and there, so it has two when it gets passed in. Okay, let me go back to where we were. Here, everything looks fine. I don't need const. Cool. Okay, I think that's everything. Does it make? I don't know. It's a good question. Let's do it like single line. Oh, standard error is undeclared. So we need to include the right library, which includes those methods. I'm going to put it here, even though I'm not supposed to, but this way I'll just like, I won't check it in. Everything will fall apart. We can see what happens when we try and like I can show you how that falls apart later. Why is it rebuilding all this stuff? I don't know. Maybe because I touched the wire messages. Good question. Slow. Not rebuilding everything. Maybe. Let's see, we've got like 40 more minutes. We might not have time to solve a bug. That's okay. We're gonna try it, and this is fun. Oh god, I should have used J.
Yeah, Nifty, just kind of a little outline, just like the things we were planning to cover was just kind of the buckets of C Lightning, where it's like, you know, there's like the spec compatible C code, and there's like the plugin architecture that you can use for not C code if you want to like start getting contributed there, and then the Python test library. So if you can like cover those three for like first time contributors.
Okay, cool. Yeah, I can do that. Let's see how far we get on writing this RPC. What we're doing right now, even though I didn't tell you, is we're adding a new RPC command. We'll see how far we get. Cool. So it builds. So that works. So my new like message is in. Yeah, okay. And then, yeah. Okay. So yeah, so now I've got this like little handle message thing. That's cool. Okay. So now what I want to do is I want to go to lightning-d channel D controller. And I'm gonna add like a new I'm gonna add a new JSON command. We're gonna call it static const struct. Yeah. JSON command dev, I don't know, no nifty, send message. So what I'm doing right now is I want to add a new like RPC command to core lightning so that it prints out a message from the daemon just because I can. I don't know. And send nifty. Oh no. Nifty send message command. Cool. So this auto data thing is like kind of fancy C magic that Rusty wrote. What it does is it takes this like struct stuff and adds it to this like global data structure that then gets read somewhere else in lightning-d. So when you send, so this basically it lets us like declare RPC methods anywhere we want in the project in lightning-d, and they'll like automatically get like added to some general registry at compile time that then core lightning knows how to like find and like register. It's kind of just like a nice little like thing for keeping your code nice and neat. So nifty message. So anyways, I'm gonna, the new thing, the new command we're gonna call nifty message. It's a nifty type nifty. These don't matter. This is just like a printout thing. JSON nifty message. And then this is a method we're gonna have to write. And then print a message. Standard error in channel D. Oh, okay. Okay, so I'm just gonna copy this one. I'm not a developer. FDev. I don't want it to be an FDev. Okay. Yeah. Did I just mess something up? No. Sorry, I get confused. I do this sometimes. Let's just put this here. Otherwise, okay, cool. Okay. Oh, I see what happened. Okay. I copied this and I'm gonna put it up here. Sorry, I got confused. Okay, so this is gonna be my like method called JSON nifty message. So this name right here is a method that I've declared right here. I take some stuff in it. Check the style guide if you're doing stuff about how to like format things. They need to be lined up. You always have to have tabs. Tabs need to 8 spaces, you know, that kind of thing. And then like, I don't know, usually when you like get a message in, you first stick parameters out. I need to send it to a node ID for reasons. Sure. And then this would be like the message to send, right? And it would be a param. I think you can just do like string, param string, and then pass it into the message to send. Message. Where is that? Anyways, so these are like basically things that we're gonna read out of when we send like the RPC over, we're gonna send it. These are like the parameters of it, an ID and a message. So let's say like pure ID. Pure ID. Cool. That's that. Both of them are required. That's what the REQ stands for. I also need a char star, which is message. I think that'll work. Sure. Yeah. Okay. And then, I don't know, I gotta look some stuff up. We have to look up the peer idea that we did. And then. Okay. I'm just gonna basically copy this guy over. So we're gonna look up the peer ID. So I'm gonna make it such you have to like send it to a particular channel because you could have a lot of channels. So we'll just like pick one. So this is how we make sure that that peer exists. So it's not ID, it's peer ID. Peer might not be connected. Oh, I need a peer object then. Struct peer. I don't actually. I'm gonna make sure they have a channel that exists. Like this here, this line here. I don't know if there's more than one is. Sure, we'll just fail if there's more than one. I think that's fine. Yeah, that looks cool. And then I'm basically just like copying this whole thing. Just gonna copy that. Yeah. Where's the message go? I don't know what the message is. Message here at the bottom. Oh, okay, yeah, that makes sense. Okay. That's all the stuff I need. Okay, so then instead of channel D rates, we're gonna do channel D nifty message, right? I don't know what this null thing is. Actually, I do know what it is, but I'm gonna ignore it. And then I would just send in my message. I think that's it. I think that's all we send, right? We can go check in wire gen. To wire, send the string and this thing called a context. But this context thing has to do with like memory allocation in C. It's this really nifty library that Rusty wrote called Tal. Basically it like helps you handle like you have to we're going to allocate like a buffer basically to write this message to. So when the message comes back, it's been allocated. Tal stands for tree allocation. So we're going to like allocate some stuff around the whatever, I don't know. Yeah, so that goes into the message and then we send the message over to the channel owner, which is cool. So this little like sub D send message is like the magic that sends the uses the this is actually how you send the message over. So that sends it over to channel D, and then basically we'll say like, hey, we sent your message. So JSON add string, I think is the thing I can do. Response success. Like, we sent the message. Okay. Cool. I think that works. Make. No, use make J. I know. There's a problem. How did this happen? It wants an and sign in front of this. F and cool. Cool. Doesn't like that. Oh, I think oh, it's called ID. I like messed up. Okay, sorry. I just like name things are wrong. Okay, cool. This time for sure. No, I didn't like something. Peer ID, incompatible pointer type, expected, node ID star star. Oh, okay, fine. This time for sure. No. Param string from incompatible pointer type, expected const star, but is of type char star, which means it wants me to put the word const here. Fine. Fine. I think that'll be fine. This time for sure. Okay, cool. So now it works. What does that mean? We stop ln, we start ln, back up again. Oh no, I think that's okay. L1 CLI type help, and we look for our nifty message in there. Wow, look, we just added a new RPC command. That's cool. Cool. And then if we do L1 CLI, list nodes, list peers, channels back up. I can do L1 CLI nifty message tier Hi, this is a new message. We got a message. All right, so just printed it out. Remember, because whenever we get it, we just like said print to standard error. So that's why it's just like barfing it onto the onto here. But I don't know. Actually, that's hard to see. Sorry. Let me like move this around. I don't know. I could say something else. Something else. Okay, cool. That was a lot easier than I thought it was gonna be. Okay. We've got like half an hour. Do we want to try and like solve an actual bug? So Kody, you said to go through the Python stuff and
Yeah,
plugin
just
architecture.
just if you just talk about the architecture side of it, of like there's the spec compatible like the C plugins and like all that kind of stuff that's like very like per spec, and then there's the plugins architecture, you can kind of hook into those things and write it in whatever language you want.
Yes.
And then if you're like a Python programmer and you want to like start contributing, there's like the whole Python test suite. Cool.
Yep, that's right. Yeah, that's a great point. Cool. Okay, so this is my really ugly message thing. Okay. Yeah, so plugins are really cool. Plugins are, how to explain plugins? Oh, we already looked at plugins. We saw that plugins are like this PS tree thing, right? Where'd it go? PS tree. Yeah, so like these little plugins and stuff, the ones that are like all here are all written in they're all written in, what language is this? C. And they're all kind of included in the project. But as Kody was mentioning, you can also write them in other languages. So we just went through how you would like add an RPC to like Core Lightning and have it send a message to one of its like subdaemons, right? Which is pretty fun. The stuff for like lightning-d though, there's like lightning-d plugins. Plugins are kind of these like things you can add to your node and run, and some of them are written in like Python and some of them are written in like Go. I have a whole Go thing. I don't know how out of date this is. I don't know if it still works. But I have like a whole like, you can write them in Go. You can use the Go plugin framework that I wrote. You could use there's like a Python one, which is what all these guys use. So let's like find an example written in Python. I really like summary. I use summary on my node. It's like a really nice little thing. You just type in summary, lightning CLI summary, and it prints out a summary of where all your data, all your money is, and what your inbound, outbound looks like. You can just like, it's really short though. Like, look, this is like the whole thing. So if you click into summary, it's like a Python thing. And the key to writing plugins, oh, I keep opening it the wrong thing. It's cool. So the thing is, it uses this thing called like PyClient. It imports the plugin and millisatoshi stuff. So like there's a Python package called PyLN, and it's got all the stuff you need to build a little plugin. You just like start a plugin object, and then you have to pass it kind of some special, you need a Python, you need a init message for your plugin, which gets like some options, configuration stuff, and the plugin itself. You can add little subscriptions, so you can subscribe to things when things happen, and then you can add options to it, and then you call run at the end in Python. So this is again like it's a little process program, right? And so it'll just magically do stuff, and you can add commands. So like a method, summary method gets implemented here. So when you call lightning CLI summary, this is the code that'll get executed. So it'll just do all this, and you can call the RPC from here. So this one makes little RPC calls to get info, list funds, and list peers, which is what we've been doing right all today. But you can do them in code using a little RPC library. And the RPC library is part of the plugin, but then you can also set it up. And I think PyLN client has like a whole RPC thing. And there's also one in Rust now, which I've never used. I don't know a lot about it. I know that Kody is working on some stuff that's using a Rust plugin. Anyways, cool. So these are just like a bunch of third-party plugins that someone else wrote. Note that they're going to be running on your machine, like having access to like basically your Lightning node. So not sure I would just like randomly pick one at random, but yeah, if you know of one you like, it's cool. The ones that ship with Core Lightning are pretty trusted. Cool. Okay. So those are plugins. Those are pretty cool. we could write a plugin. What I really want to do though in our last like 20 minutes of hanging out is I wanted to see if we could fix a bug. I don't know if that's fun. Wait, was there anything else, Kody? So we talked kind of through plugins.
Yeah, so just like for like first time contributors coming into Core Lightning, there's like we were saying is that there's this whole the C side, which is like the spec compatible. There's like all sorts of rules for like the tests, the error messages for them, like they actually reference within the spec, like the thing that's supposed to happen, right?
Yeah.
So that's like not like if you're just like coming into the project, like a thing that you can start jumping into like initially, right? But then like with all this plugin architecture, like the stuff, especially outside of Core Lightning, stuff that just kind of hooks into it, like those are all in whatever language you're most familiar with, like good places that you can start in, like writing documentation for them, doing additional testing and all that kind of stuff. And if you make one of those plugins super slick, like Commando, then that's something that might get like pulled into Core Lightning and like rewritten as a C plugin that ships with it by default, right?
Yep.
So
Yeah, that's right.
Kind of like for first time contributors sort of thing. And
yeah,
then
exactly.
the other one was the Pi proto test and just like the Python testing library stuff for within Core Lightning.
Yeah, we can do that. Okay. So what I wanted to do is like, I don't know if we can do it in 20 minutes. Maybe we can do it in 20 minutes. I had a bug. I found a bug that I let. So if you try and make a liquidity ad happen without enabling experimental dual funding, it doesn't warn, it just creates a regular channel. So if you were trying to buy a liquidity ad and you didn't have this flag turned on, it doesn't warn you. It just like exits anyways. So we should add a warning, right? Or like if you pass in this like parameter and you're not running is this going to be hard to do? I don't know. We'll find out. Okay. And you're not running a channel. You're not going to be able to open for whatever reason. If you can't do a dual funded channel in your config flags, we should like error and not let you do it. Because you were trying to do something, we shouldn't let you do the thing. Okay. This is a great idea. So they're like complaining because they opened anyway and they paid to open a channel and like they didn't get any money on the other side because they didn't have the right thing turned on. Okay, so I think the easiest way, so what's kind of fun about this, I think, is it'll give me an opportunity to like show you how I find things in Core Lightning. So I want to make it such that if you pass in this request amount or a compact lease, I think you have to have a request amount, that it'll just error if it can't do, oh no, wrong button, I do a lot. Okay, so I'm just gonna copy. So what I'm gonna do is I want to find where this like parameter gets read in. So request amount. So this little GGN thing that I'm using is a get grep n. So that just shows you, it greps all the files in Git, and then the -n shows you the line number. So that's really helpful for me for like finding stuff in the project. Cool. So I'm actually going to go here. Oh, it's in dual open control. I think it's here on this def request amount thing. Okay, so I have a couple things that I want to check here, but generally it's going to be somewhere in dual open control. So this is a file I'm going to go look in, and these are the two file numbers, line numbers I'm going to look at. So I use them to go here. Oh no, I think it was in opening D. No, it was in lightning-d. What were the two numbers? That's so hard to read. It was 2595 and 3314. So 2595. Aha, okay. Okay, so the thing is, like when you get here, when you get to this point, this JSON channel init thing, you're pretty much guaranteed to be able to. Oh, is that true? I have a hunch that if you get here, like you can only get here if you have like your open channel like declared. So I'm gonna look for actually let's check. Yeah, so we'll error if you manage to call this function this without the dual funding feature like set up or whatever, you'll like fail. So the problem isn't here. This is fine. This is doing what I'd expect it to do. Problem is somewhere else. So let's like figure out where that is. So where in this project do we call this? I'm gonna give you a hint. We call it from a plugin. We're calling it from the funder plugin. So we're calling it from this funder plugin. in this open channel file. So I'm going to go into one of our built-in plugins who's calling this RPC command, and I'm going to look at the problem and it's there, so to speak. What line number was that? Line number 988. Okay. 988. Cool. Okay. Here. We make a decision to do this somewhere. So where do we call this? Somewhere we like call this. So I want to go back up one more and figure out where we're calling this from. Not here. Basically tracking some stuff back. It's in where am I? I'm in open channel. It gets called here, which is in this multi-fund channel thing. Okay. This is the like most massive of plugins. It's like probably one of the most complicated things I've ever worked on. It does some cool multi-fund channel stuff. Okay, here. Here's where we either call the open channel or a fund channel, and it's with this little like is v2 thing. So is the destination protocol open channel? Okay, so here's a thing. So before we get here, oh my goodness. Let's say this is v2 thing is open v channel, GG open channel. Okay, where does this get assigned is my question. Open channel, but I only want to look in this plugin spender guy. So somewhere I'm setting it to the thing here. So I'm going to go to this line 1618 1618. So we check to see if this feature is negotiated, et cetera, et cetera. Okay. So we connect to them and then we see which open protocol to use now. Okay. So at some point here, I want to see if you passed in the wrong. So there's like this really like complicated thing that's going on here. It's kind of hard to explain, but the problem is that like I'm doing all this connect stuff. After connect, okay. What happens after connect, okay? Get fee rate. It's gonna go in like a whole little like thing. Let me like GGN for this one. This doesn't get, it does get in 1894 6086. I don't think we want to look in here. We could. The plugin spender fundchannel.c. This is where it gets declared. It just like basically this just forwards it over to another like plugin thing. This is like where it gets really convoluted and stuff. Where's 1894 in multi-fund channel? 1894. Okay. 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 Destination. Okay. Cool. Okay. So this is where this gets called param destinations array. Request amount. So this is an optional thing and it'll be set to 0. Cool. Okay. Okay. Param destinations array. Let me go back one more. Tab. Okay. There was the thing where I said it was GGN open channel. This one. Sorry, I like forgot what line I was on. I wanted to be at 1618. Okay. 1618. Here. There's a point in here where we want to fail if you've like, how do I say? If you protocol. If you have connect done, what happens here? After multi-connect. Check if anyone failed. Okay. So I think what we want to do, so the connect failed. Why fail? No, 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 fail. Sorry, I'm like trying to figure out how to do this. Basically what I want to do is, so if, okay. Here. So if the destination, hang on. So what I want to do in here is I want to check that. So if it's a V2 open, right? We're planning on using the V2 open stuff. Oh no, hang on. If it's not a V2 open, else. If it's not, so it's not a V2 open. So like we and or our peer don't support the dual funding thing. And what your destination, you've set like a request amount. If else, if amount, what's amount inside? Inside 0 should be a thing. So, but if your amount that you're requesting is not 0, but you like, okay, so if it was a V2, we would be in this if block. But if we're not in this if block and you've requested a request amount, we want an error. We want to throw an error, return an error, right? Okay. The other thing we probably should check here, honestly, is the request amount. No, this is not the destination. We have a dun, dun, or if like, or if this destination lease rates is not null, right? So if either this variable is set or this is not 0, like we're just gonna say there's a problem. The thing that's not cool here is that like, by not cool, like we've kind of lost some information at this point. It's fine. I'm just gonna return an error. I gotta figure out, and I just have to like figure out how to return an error for this one. GGN state equals multi-fund channel fail. No, doesn't like that. I have like 10 more minutes. The multi-fund channel 41. Failed destination. Okay, so all I have to do is say failed destination. Okay. Kind of sucks that there's no way to send an error, but I guess that's okay. Fail destination. Destination. There's a message. Oh, I can't add a message. Okay. Fail destination with a message. This is like fail destination. Can't read this. Let's go somewhere else. What are all these failures? V2 not supported. Okay, great. We can return this error code. Tried to buy have what was it, experimental dual fund. Enabled. Okay, I'm gonna run out of time. I didn't get to show. Well, that's okay. And then I think like Mm. Okay, so I don't want to like reset it here, else I'll do this. And then, okay, right, okay, cool. I think that fix it. I think that'll fix the whole thing. Okay. See if that works. It's building. No, didn't like things. What is it not like? Incompatible type for this. Are you expected struct mset, but a type is struct amount set. Okay, that's easy to fix. There is no member name, least rates. Oh, it's just called rates. I think maybe you have to do this. It'd be fine. I don't know if that's fine or not, whatever. I don't think that's wrong. Cool, okay, that builds. So now we need to test it, right? So we've like changed the behavior and now we wanna like try this, right? Okay, so the way that we would try it is if we're being like super lazy, we could stop and restart our little local things and start LN. I think that we can now like fund channels, like 2 channels between nodes, right? Oh, I actually think I have experimental dual fund turned on. Okay, that's gonna be too lazy. Let's just get rid of Python test. I've got like what, 8 minutes. Okay. So Kody wanted me to talk about the like Python stuff, which is cool. It's cool stuff. Okay, so I'm gonna quit this builds, which is cool. In the test, so we like there's several layers of tests in Core Lightning. Each of the little daemons has its own test file. These are all like C tests, C unit tests. They're written in C. They're their own little C projects. You just write a little C project and write some assertions, and then it'll get run when we run the unit tests. It's pretty nifty. But there's also these like higher level Python tests. So if you know how to like do Python and stuff, we have some tests that are written in Python. These are full like integration tests that actually like spins up 2 nodes and has them talk to each other, which is cool. So we use like the RPC to like call commands and make them chat with each other and then assert things based on what's going on exactly. So I'm gonna get, I think, into test. No, it's not test pay, it's test opening, because we're gonna test opening a channel, right? Let's open test opening.py. I'm gonna do one. So this is only like v2, right? So it's gonna be test query rates. That's not it. Test mix 1 and v2. We don't want to do that. Test open to vig restarts. This sounds like kind of fancy. Let's just, it's not just like a simple test open. That's fine. That's cool. Let's put it at the bottom. Test v2 open. Oh, actually, this is just a v1 test. That's cool. Test try v2 test by liquidity. No v2. Okay. Was it request AMP? Okay. Just copy some stuff. I don't know what this actually do. Test closing has one. Test closing looks a lot neater. Yeah, test closing. Request AMT. Okay, that was easy. Where does it get reads from? I don't know. Okay, I'm just gonna copy this. I'm just gonna paste it in here because this is a lot easier than whatever. Oh no, it's at the bottom. Okay, so I need 2 nodes. I can use node factory, just get 2 nodes to talk to each other. I should probably like leave a little thing here. Probably leave a thing, test that you can't actually request amount for a channel for a node that doesn't support E2 opens. I don't know. Okay, that's kind of a not a great thing. I only need 2, so node factory is 2. I don't have any ops, I don't think, at all. So let's do that. We're gonna connect the nodes. I need to fund them. Fund wallet. Why does it keep going in the wrong place? I only need 2. It'll blow up if I don't do this. I'm gonna fund my wallet. I'm gonna connect to L2. I'm gonna ask L2 what their rates are. That's not gonna work because I don't think they've had their funder stuff set up. Hang on, really fast. Speed test closing. This is like, okay. Test opening. Just kidding. I need some stuff. But only want L2 to have these just for reasons. So only L2. So that'll make it such that only L2 has them. That's cool. Okay, so we fund the wallet, then we connect to L2. So we connect to L2, localhost on their port. Then we ask what the rates are for L2. Just fine. I don't think that's actually gonna work, actually. It's fine. Let's see what happens. Is that gonna work? I don't know, we'll find out. Then we wait for list periods to be 0. Then we connect again. Then we attempt to, so then this should fail. So this right here should fail, right? Because we're using request amount. And we said that if you do request amount and you don't have the 2 open, which we don't, it'll fail. Okay, so I'm gonna run this. I should close this, it's easier to see. Okay, so what I'm gonna do is I'm gonna make my thing. Usually I do quiet, and then usually you need to like do this, like, how do you find the Python? Usually then you need like a huge make j quiet format thing. Yeah, thanks, Kody. Let's go away. Cool. Yeah, I think that'll work. Question mark. So then you need like to set this Python path thing. I think this is all in that hacking.md thing I showed a while ago. Then I also like at the end you run like, you can't see it really. There's like PyTest, and then you do -k. I think I need to do tests, PyTest. I think I have to do, maybe this is why my thing wasn't working earlier. PyTest tests, and then K is like basically run this one specific test. So I'm gonna run this new test that I just wrote. I'm almost out of time. Let's see if it works. It might fail. It's running. That's cool. Did I turn Valgrind off? I did not turn Valgrind off. This is gonna take a while. Okay. Well, that's nice. It failed. Why did it fail? Amount is not defined. Okay. Well, where's amount? Amount is here. I don't know. Let's do amount equals like 10 times 10 to the 6. That should work, right? That seems like, this is a channel open. I don't know. That seems fine. I don't actually need the 10. I think that'll work. Amount is not defined. Okay, I'm turning Valgrind off. We can turn that on later. Valgrind is great. Valgrind is great. Go. F failed. Failed a lot faster that time. That's positive. Oh, fee rate is also not defined. Where did I get this test from? Let's just go grab some stuff from there. Is that it? Yeah. Oh, okay. These look fine. Insufficient funds? What? Oh, okay. Same sketch. All right. Times 100. L1. L1's funding the channel, right? Yeah. F. So I'm expecting it to fail, right? They have query rates. doesn't exist. I don't actually think I need to call that. That's dumb. I don't actually need to call this. I don't actually need to connect again. I could just make something up. Right. And this request amount could be, this is fine. Like, haha. Doesn't actually have to be anything. Actually, that's going to fail. I should probably not include that. Okay. I expect this to fail. And I expect it to fail for different reasons. I don't actually even need this set up. It should fail. It should really fail because I filled in an amount in the request amount and it should not allow me to do that. Oh no, this isn't gonna work. Hang on. That's that thing. That's cool. Okay. Should fail fast, hopefully. Fails. Looks like we got an RPC error. Must pass in compact leads if requesting funds from peer. Oh no, okay. Ugh. I'm almost done, I promise. To have like a compact lease that's just handy. I don't just have like an example compact lease. That would be too good, wouldn't it? I need a compact lease that'll parse. What if I just do, I need a compact lease equals string. It needs to be like valid though. If it can't actually parse it, it'll fail. Let's go grab one off the real internet. Go gadget. Lightning. I'm almost done, I promise. We're gonna go over like another like 5 minutes. So if you need to drop off, that's cool. Maybe I should go ahead and do like the thing. Okay. List nodes, grep, I don't know. Option will fund. That's not really helpful, is it? I should probably print some stuff out after. I don't know. Does that work? Yeah. All right. I'm just gonna steal this. Cool. All right. That should work. Hopefully. So I'm going to exit this. Okay. This should fail, hopefully quickly. So then what I'm gonna need is a with dot. This one. Okay, so it failed. So I need to change my test so that we expect it to fail. Please tell me it like failed for the reason. What does it say? We don't have, all right, there it is. We got our error message. Dope. We tried to buy liquidity ad, but we don't have experimental dual fund done. Okay, cool. Great. So all we have to do now to make this thing test is we need to put it in here. Crap, there's a. Okay, so now this test should pass. Should pass now. No. What's it say? Unknown position at, oh gosh. This is so this is a regex here. So I just need to wrap, I think I can wrap this whole thing in. Dustin taught me this little trick, I think. So I can just wrap this whole thing in quotes now. Don't use weird stuff in your, error strings. The lesson. Look, a green dot. Great. We win. Everyone wins. Cool. Yeah, we made it pass. Okay, problem solved. If I want to be really whatever, I'm gonna run with Valgrind, which will, Valgrind is like this really weird, not weird, that's the wrong word for it. It's like a C memory checker, so it makes sure you're not like doing anything you shouldn't with your memory in your C programs. Takes a long time to run though, because it like I don't really know exactly what it does, but something about like heap traversal or something that might not even be a real thing, but it basically goes through and checks. Okay, cool. So still pass. Great. Okay, so we're done. There's like some other checks that are probably good to run, like make unit tests or make check units. There's like a whole test suite we could check. But the one I'm gonna check is just to make sure that my Python is correct. Yeah, okay, cool. So let's check out a branch, nifty, warn, no dual fund. We're gonna add all the stuff in. Oh, we don't want that. No, we don't want any of the stuff related to adding a new message, right? We don't need that. This I do want, right? This is my, like, if you've asked for stuff and whatever, we're gonna say yes. And then this is my test that tests that is actually correct and we get the right error. And so I'm gonna commit it now. I'm gonna say, I don't know, dual fund, fail if you try to open a channel to buy a liquidity ad without dual funding on. And then, so like, then I would explain a little more. Maybe I should link to the error. This is fixes 5271, right? Fixes 5271, 5271, in collaboration with Base58 encoding seminar participants with wave. Cool. Okay, I think that's good. Oh wait, I gotta amend that. Forget to add something. Change log, changed. I don't know. What is it? Fun channel. Warns now. Errors to buy liquidity ad, but don't have experimental dual fund enabled. Cool. Great. Cool. Great. And then I can go to pull requests and open up a pull request. That's the whole thing. Oh, I don't want that command. Hang on, I gotta edit this really fast. I have too many commits. Git rebase I master. Oops. Check out that. Ooh. Git log. Okay. Cool. That was only one commit, and it's the whole thing, and it correctly says the thing, and it should work. Okay. So if you want to help review something on Core Lightning, you can check this out and look through it and see if you have any comments or concerns about. If you review would be much appreciated. Cool. Okay, I went over 10 minutes. I apologize, y'all. I'm gonna go ahead and stop my screen share. Hopefully that was super informative and kind of fun. Yeah, I think that's everything. Kody, did you have any like last minute like plugs? I guess we should talk about.
Yeah, so just the last couple things for like getting like joining and like starting contributing to Core Lightning is that they've got a Discord channel where everybody is pretty active. And so if you post in this like dev chat channel, normally Rusty replies if he's awake. He's in Australia, so it depends on the time, but he'll reply within like 5 minutes normally, depending on whether or not he's doing something. So if you want to get started, that's like a good place. We've got like start here, newbies, all those things. That one. for plugins architecture, there's like the stuff within Core Lightning, but there's also the lightningd/plugins, and that's like community curated plugins of just a bunch of random stuff. Like I think PeerSwap is like a Go plugin for Core Lightning is the way that it's implemented. And so just like whatever language you like writing in is that you can write plugins for Core Lightning. There's probably something already out there for you to play with. Then you can follow Core Lightning on Twitter as well, core_LN. The GitHub is elements project /lightning. And then this REPL, I didn't really go into it too deeply, but basically you just go to the link that we posted and then you fork it off. And then you just walk through the markdown for it. And it just gives you all the instructions, like setting up the reg test environment that Nifty did, opening a channel, connecting, opening channels, and then you can do a liquidity add and then dual fund a channel for it. And so that's all that stuff. And then Base58 things. Well, we don't have an upcoming transactions class. We're currently going through one, but we do have a Taproot class that's going to be coming up. It's going to be like a 3-day course that Nifty tweets out about when the
Maybe longer. We'll see how long it goes for.
Okay, well,
3 days, three days, question mark number of days, but yeah.
Yep. And then next week when we do this, it's going to be with Minimint, which is a federated Chaumian eCash implementation, and that's going to be with Justin Moon and maybe El Syrian if he's in the mood. But Justin's going to go through, and that's a Rust project, and I just started contributing to it, and so I'm going to have a PR that Justin's going to review while we're going, and so you kind of see how to get started with that one. So yeah, I think that's everything.
Cool. Awesome.
Yep.
Thanks for hanging out, y'all. Hope to see you next week.
Bye, guys.